How do electricity and magnetism laws apply in GED science? Imagine holding a balloon after rubbing it on your hair. The balloon sticks to the wall because of static electricity. This simple trick shows how electric charges can create forces. In GED science, especially in physical science, the laws of electricity and magnetism explain how these forces work and connect. These laws help us understand everything from how our appliances operate to how magnets stick to the fridge. Electricity involves tiny particles called electric charges. These charges can be positive or negative. When charges are still, they create an electric field around them. This field can push or pull other charges nearby, which is called static electricity. When charges move through a wire, they create an electric current. This current powers our lights, computers, and TVs. Magnetism is related to moving electric charges. When charges move, they produce magnetic fields. Magnets have two poles called north and south. Opposite poles attract each other, while like poles push away. This attraction and repulsion are what make magnets stick or repel each other. The link between electricity and magnetism is called electromagnetism. When electric current flows through a wire, it creates a magnetic field around it. This is how electromagnets are made. For example, wrapping a wire around a metal core and running current through it turns the core into a magnet. The more current or coils you add, the stronger the magnetic field becomes. One important law is Coulomb's law. It explains how electric charges attract or repel each other. The force depends on how much charge there is and how far apart the charges are. The closer the charges, the stronger the force. Opposite charges pull together, and like charges push away. Another key law is Ampere's law. It tells us how electric currents produce magnetic fields. If you run a current through a wire, you can calculate the magnetic field around it. This law helps us understand how electric motors and transformers work. The right-hand rule is a simple trick to find the direction of magnetic fields. Point your right thumb in the direction of the electric current. Then curl your fingers. The way your fingers curl shows the direction of the magnetic field around the wire. The electromagnetic force is the combined effect of electric and magnetic forces on charged particles. It explains how particles move in electric and magnetic fields. This force is what makes electric motors spin and generators produce electricity. In everyday life, these laws help us understand how devices like motors, generators, and transformers work. Electric motors use magnetic forces to turn motion into electricity. Generators do the opposite, turning motion into electricity. Transformers change the voltage of electricity for safe and efficient power delivery. So, in GED science, understanding how electricity and magnetism laws work helps you see the science behind many common devices. These laws show how electric charges and currents create magnetic fields and how magnetic forces influence electric charges. They are the foundation for many technologies we use daily.